Hello and welcome to this video where we will be using a Cascoda sniffer along with Wireshark to analyze our KNX-IoT network traffic. So here we've got our sniffer, and then we've got two KNX-IoT devices, and those are very simple devices where if you press this button on one device, it toggles an LED on the other device and vice versa. Right, so let's get started with that. Now, if you take your sniffer connected to your PC, now I will note one thing. In order to follow this instructional video, you will need access to the Cascoda Windows tools, which are publicly available at github.com/Cascoda SDK. And then if you scroll down to the releases here, all you need to do is download the Cascoda Windows tools and then follow the installation procedure. And that will give you access to the following applications. So number one is Chili Control. Number two is Serial Adapter. And number three is Sniffer. So today we will be using Chili Control and Sniffer. So already let's use Chili Control. If you do Chili Control list, you should see that your sniffer is attached to your computer. So that shows up as a Chili 2 device with the Mac dongle application. And here you've got the serial number for that device. So next up, we're going to fire up our sniffer. And the way we do that is using the sniffer application, provided with the serial number thanks to the -S option. So you copy paste that, and then -W to open Wireshark. And then next you need to enter your channel number. Now if you've configured the devices onto the thread network using the KNX-IoT hub, then you can simply access the GUI and then head over to network thread, and here we have channel 23. So here we type 23. Now for the purposes of this demonstration, before I go ahead and enter this command, I'm going to disconnect those devices. And then now, if I fire up this command, let's see what happens. So here you can see Wireshark is open, and it is actually already in capture mode, and it is now capturing all of the IEEE 802.15.4 network traffic, which at the moment, as you can see, there is none, and that makes sense because we've disconnected our devices. So I will go ahead and connect those now. And as I do that, you should see some network traffic start to appear. As you can see, we have a lot of packets appearing, and if we look at the Wireshark interface, you'll notice that there are columns at the top. So this one tells you the order in which these packets are received by the sniffer. The time column tells you at what time those packets were received. And then here you have the source addresses, the destination addresses of the packet. And then here a very important field, which is the protocol field, tells you what protocol this packet is from. And then finally you have the length of the packet and some additional information. So let's have a look at what kind of packets we have here. So here we have some MLE packets, Now MLE stands for Mesh Link Establishment, and that's a protocol within the Thread protocol. Now because Thread is a self-healing, self-configuring mesh networking protocol, the mesh link establishment basically sends packets which allow for the mesh to form links with itself automatically. So if we look at the info section here, it's empty. And if we look down here for more information, and if we expand mesh link establishment, you'll see that we cannot decrypt this packet. Okay, so this is a packet that is encrypted that we cannot currently decrypt. We'll solve that in just a minute. Let's have a look at the other type of packet, which is the IEEE 802.15.4 packet. Now again, those are encrypted, as you can see, and we cannot yet decrypt them. So we don't really have any information about those. So let's scroll down a little bit here to the end. And now I will simply press a button on a device and let's see what happens on the network. As you can see, once I've done that, we have quite a bit of traffic generated, which again we cannot yet interpret. Right, so now how do we decrypt this kind of information? First thing we need to do is we need to be able to decrypt the thread packets because all of the KNX-IoT protocol relies on the thread networking protocol. So the way to do that is if you navigate over to your KNX-IoT Hub GUI, network thread, and then here you have your network. If you click on edit, scroll all the way down, and then here you have your network key, which we will copy that and then head over to Wireshark, go to file, go to edit, preferences, protocols, find the IEEE 802.15.4 protocol. Now you see here you have decryption keys. Click on edit and add a new decryption key. Here we will paste the network key, and here you have to select thread hash. Let's click on OK, OK. And already here you can see a lot has changed in the Wireshark interface. So first of all, we've now been able to decrypt the MLE protocol packets. So here you can see this is an advertisement, link request, link accept, data request, and you can get all of the information here in the bottom left pane. You can expand all of the fields, look at all of the data. And other than that, we can see that now we have some 6 low-pan packets, some UDP packets, and then if we scroll down further, some OSCORE packets. Now the thing to note about the UDP packets is that they are actually a higher level protocol which is using UDP, but Wireshark is currently not decoding them as the higher layer protocol. So we need to fix that. Now the way to do it is, first off, you can use the display filter here at the top, UDP, enter. So now we've got only the UDP packets. Now those UDP packets will be either CoAP or MDNS. So what we have to do here is right click, decode as, and then you have to try either CoAP or MDNS. So let's try CoAP. If we click save. So as you can see now, a whole bunch of UDP packets have been decoded as CoAP, which is good because now we can see that, oh, this is a CoAP post on the /a/AQ resource. So other than that, we still have some UDP packets. So this one will probably be an MDNS packet. So let's decode it as such. If we select MDNS, save, And yeah, that was an MDNS packet, and so was this one and many other ones. So let's now have a look at all the UDP packets, and you can now see that they've all been decoded either as MLE, as CoAP, as MDNS, or finally as OSCORE. And in fact, you'll notice that already by setting the thread key, we've been able to decrypt all of the packets except the OSCORE packets. Now, OSCORE is a protocol used by KNX-IoT in order to securely encrypt data. So, as you can see here, it says security context not set, can't decrypt. So if we want to truly understand what's happening on our network, then we do have to decrypt those packets. Now, doing so is a little bit more complicated than decrypting the thread packets, but I will show you how to do that now. So initially, when you've configured your devices, you would have done so using ETS. And if you've done so, then if you navigate over to Reports, so I actually have the reports pane already opened here. If you go over to Project Security, you'll see some document here. Now that document contains the keys that you will need. So you need to export that document. I've already done so, so I will go ahead and open that now. Alright, now this will allow you to copy and paste those keys. You'll notice that you have one key per group address. So you have a key for group address 001, another one for group address 002. This is relevant, and I will show you why. So if you head over to Wireshark, now just to generate some more traffic here, I will actually press the button on this device, and I will also press the button on the other device. This way we trigger both group addresses. Alright, so if you have a look at this first one, what we need to do is expand the CoAP section here. So Constrained Application Protocol. If you expand that, you will notice there are two important pieces of information. The first one is the key ID, so that's 0002, so that corresponds to group address 2, meaning if we want to decrypt this packet, we will need to use this key over here. Okay, so let's copy that key. And the other important piece of information is the key ID context. Okay, so let's keep a note of these two pieces of information, and let's go ahead and right click on this packet, go to Protocol Preferences, Object Security here, and then Security Contexts. We will add a new security context, paste your key into master key, and then here in sender ID 0002, so that's the same as your key ID. And then here we have the ID context field, and this is where you put in the information that's written in key ID context here. So you can right click, copy, value, and then let's go over to this menu again. And then we will copy that here. So we will paste it. Okay. And finally, we can see that we can completely decrypt this packet now. So nothing is encrypted, all of the data is available. And I will show you how to interpret this data in a second. But before we do that, let's go ahead and also add the security context for the other group address. So you'll notice if I click here, this is still not decrypted, so we need to repeat the process. So first off, verify that the key ID is 1. Okay, so we will go over to our security report, copy the key for group address 1, right click, security contexts, add a new security context, paste the master secret, sender ID is 0001, and once again we have to copy the value of the key ID context. So right click, copy, value. So let's paste that in here, paste, okay, and there we go. So with all of the steps that we've done so far, we're now able to decrypt every single packet that is on our KNX-IoT network. So now all that's left to do is to actually interpret the information. So let's have a look on how to do that. So to make it clear, what I'm going to do is, if you'll notice, this device here has its LED turned off. So if I press this button, that will cause the LED to turn on here. So what we'll expect is some kind of packet which encodes the information that we want to turn an LED on. So let's see how that happens. I'll click this button here. LED turns on. Now if I click on this packet, if we go over to concise binary object representation. Now concise binary object representation is also known as CBOR, and it is a format. So our data is encoded in this CBOR format, and if we expand that, then you'll be able to see that we are writing the value true. Now this might be a little bit hard to interpret manually, so I will show you a way of doing this in a much more useful way and much easier way. So if you open a website called CBOR Playground, now if we head back over to our Wireshark again, if you click on this field, concise binary object representation, right click, copy as hex stream, and now if we copy that into here and then click on the arrow, then you can see that we are writing the value true. Just to show you that this is not a fluke, if I press this button again to turn the LED off, let's take that packet, let's right click, copy as hex stream, paste it here, and as you can see it says that we're writing the value false. Now before I leave you, there is just one thing to note about the addresses. When you've got those short 16-bit addresses, you can actually easily tell which device it is, because those are available in the network topology of the KNX-IoT hub. So for instance, notice that this is 0x0400. If I head over to the network topology, which is in network thread, view, topology graph, you'll see that there is a corresponding device. So that's it for this video. I hope you found it useful, and I hope you learned something from it.